What up? That's right, we're going to learn some math. Today we're going to do some stuff with variables and expressions, okay? The first thing I want to teach you about are variables. What is a variable? A variable in math, that's the thing that people always complain about. They're like, I thought math was just numbers. Why are there letters from the alphabet in there? Well, because sometimes you don't know what number you're supposed to do. So when you see 2x plus 3 equals 15, that x is a variable. That x stands for a number that we don't know yet, okay? X can stand for a number, or it can, essentially we can narrow it down to a group of numbers it could be, okay? So, for instance, in this one you would subtract 3, that would leave your 2x. You do 15 minus 3, that's 12. 3 minus 3 is 0, so it goes away. Then we divide 2, x equals 6. Therefore, 6 is x, and x is 6. That variable right there stood for 6. We didn't know that when we started. It was like a placeholder. It was saying something goes here, and now you got to figure out what it is. And that's what a variable is. Something that is in the place of something else, okay? That might not be an official term, but that's my term, and it's good enough for work. Okay, good deal. Learnage. What up? Okay, so what we're going to learn next is algebraic expressions, okay? An algebraic expression is exactly what those two words mean. It's an expression, which means it shows something, and it's algebraic, which means that it has some math stuff in it. So it's something that says math things. It's a pretty technical term right there. Okay, so whenever you have an algebraic expression, you have to have two things, okay? You have to have one or more numbers and variables, okay? It can be numbers, it could be variables, it could be both, it could be whatever. And you have to have an operation. A lot of people like to call them algebraic operations. That way you don't like say, oh, 2x and then the game operation 4y. No, that doesn't work. It has to be an algebraic expression. It means it has to be multiplication, division, addition, or subtraction, okay? So you have to have that, and you have to have some numbers and variables, okay? So, for instance, 5x, okay? That has a number and a variable. Now you're thinking, but there's no expression in there. There's no expression on their face. Well, first off, you talk weird, okay? And that's okay with me. I'm fine with people that talk weird. I just spit. That's how serious I am right now. We got multiplication, division, addition, and subtraction. I guess this should be a dot for multiplication so you don't get it confused with x, because we're not in 3rd grade, so we put dots for multiplication, okay? So, what's happening between this 5 and this x? They're being multiplied. Therefore, that's your operation, okay? So, this here is an algebraic expression. So, now let's do 5x plus 2. Yeah, hey. Okay, so this is my daughter Ezra. She's going to help us finish this out, okay? Ezra, did you know 5x plus 2 is an algebraic expression? Yeah, I knew that. That's true. That's right, Ezra. Good job. Okay, so that's an algebraic expression because we have an operation and we've got numbers and variables. That's right, that's a 5. So let's say we do xy. X times y. You've got two variables and you've got an operation. They're being multiplied. What about 2 plus p over q? Heck yeah, that's an algebraic expression all day, boy. All right, and that's what algebraic expressions are. All right, guys, what I want to do is I want to show you some examples of an algebraic expression. Okay, here's a pretty easy one. Let's say we want to do the product of 3 and x. Okay? What you want to do is you want to put this terminology into an algebraic expression, which means something we can look at and solve. Okay? First, you got to look at your stuff. Product means that it's multiplication. Okay? Product is multiplication. So 3 and x. So you want to find the multiplication of 3 and x. So you just multiply 3 times x. That's an example of an algebraic expression. Let's say you wanted to find the sum of 2 and y. Okay? Sum means addition. Alright? So therefore you're going to add 2 and y. Yes, sweetheart. That sounds great. My daughter is going to color. Good stuff. Alright, so we're going to find the sum of 2 and y. So therefore we're going to add 2 plus y. And we just turned that into our algebraic expression. And that's how you do that. An easy version. Alright, now looking at some more difficult versions of algebraic expressions. Okay, these are where people get confused because it's hard to break it down and kind of do it and then they just kind of give up. But you're not a quitter, so you're not going to give up. I believe in you. That means I believe in you. Okay, so here we go. We're doing algebraic expressions. Let's say the words they give us are 7 less than the product of a number. Those two should be two different words, don't worry about it. A number x and, that's how you spell and, 4. Okay? 7 less than, 7's key, less than is a key, product is, and then x and 4. Okay? 7 less than. That means you're going to subtract 7 from whatever you're doing here. So we can go ahead and put that down. Minus 7. We don't know, it's probably going to go here, but it might go here. We're just going to figure it out. Okay? 7 less than. Less, that means you're taking it away, so therefore it's subtraction. Then the product of a number x and 4. Okay? So we're finding product. That means, that's right, multiplication. So you're multiplying x and 4. So you're doing 7 less than the product of x and 4. So we're taking 7 away from 4 times x. And that's how you put that in an algebraic expression. Okay? Now, what we're doing next is let's do another. Let's do another more difficult one. Okay? Let's say we want to find 1/3 of the area of a number A. Okay? So we're finding 1/3 of the area of a number. Okay? So, what do you do to express 1/3? 1/3. Now, if you had 1/3 and then think of actually a number. Say you want to find 1/3 of 9. Okay? Let's just pick it. I know this isn't 9, but sometimes it helps to put a number in there. Figure it out. Oh. Ezra wants to join us. Say hello, Ezra. Say hi. Okay, good deal. All right, so 1/3 of the area of a number A. Okay? So if we're finding the area of a number, let's say the number is 9. What would you do to find 1/3 of that? You know it's 3, because you know you can split 9 into 3 chunks, and 1/3 of that would be 3. Well, how can you make this answer equal 3? We'd multiply it, okay? Or you could stick 9 on the top and divide it by 3, and you get 3. So therefore, now look at it as that 9 is a variable. So we do 1/3 times A, or we could do A over 3. Either one of those gives us our answer. So sometimes when you're putting these into algebraic expressions, pick a number that you can plug in for that variable, okay? Ezra, say bye. Say bye. That'll work. Say peace. That'll work. The thing you're wanting to learn right now is, what is a power, base, and exponent? I ask myself this on almost a daily basis. And you're thinking to yourself, I never ask myself that except for right now when I Googled it and saw this. You're in luck, because I'm going to answer that. All right, so we're looking at a power, base, and an exponent, okay? Essentially what you have is x to the 3rd power, okay? This whole thing is called a power because you have something that is being raised to this. What does that mean? Well, that means you're wanting to multiply whatever is contained by this little fella. You want to multiply it by itself that many times. X times x times x. That's what that means. 2 to the 4th power. That means you want to multiply 2 by itself 4 times. 2 times 2 times 2 times 2. Which 2 times 2 is 4, times 2 is 8, times 2 is 16. So that equals that. Like my equal sign. I did. Railroad tracks. Okay. Now, you're thinking to yourself, Mr. Tarver, you just explained what a power is, but you did not. No, you did not explain to me what a base and an exponent are. Well, this number is your base, and this number is your exponent. Okay? Therefore, you're going to multiply the base times itself however many times that number appears as an exponent, okay? Okay, Ezra, we can in 1 minute. Sound good? Cool. Good talk, kid. Parent of the year. What? No trophy? Okay. All right, so that's how we do that. And that's what a base power is. It looks like we're done here for this lesson. Okay, so what we're looking at are powers, okay? You'll see something like 4 to the 5th power, okay? While this is called your exponent, and this is called your base, the terminology still says to the power, okay? That means you're multiplying 4 times itself 5 times. 4 times 4 times 4 times 4 times 4, okay? And that's what you get, which is like a billion. Just kidding. You're going to see numbers when they have a power, they're going to increase exponentially. It's going to get bigger faster. It's not like 2 plus 2 plus 2 plus 2 and it adds up to, whatever it is. You're going to see it get big quick, okay? It's like that old question that people ask. You've got your rich neighbor and they say, I'll give you $1 million to watch my dog for a month. Or I can give you a penny the first day, I'll give you 2 pennies the second day, 4 pennies the third day, and you start doubling it. For the first 20 days, you're only going to make a few $1,000s. But that last whatever days, you're going to bank because it gets so big once you start multiplying bigger numbers, okay? That's more exponential than this. This is just powers, but you're going to see huge jumps in these mugs. Okay, so let's look at some practical equations. When they give it to us in a word problem, how does it look? Okay, let's say we'll see something like, they say the product of 4 and x to the 4th power. Okay? That means you're doing product, which means multiply 4 and x to the 4th power. Now, we didn't just do x to the 4th power. We didn't just do 4 to the 4th power. We did the product of those, which means the answer of them multiplied to the 4th power. Okay? Now, if we had done this, it would have been wrong. Because all this would have done is put x to the 4th and then just multiply it times 4. Because your order of operations is, please excuse my dear Aunt Sally, you do your parentheses first, then exponent. So you would have done your exponent before you multiplied. Okay? So whenever you read these, make sure you write it correctly because that can screw up your problem, especially when you put it in the calculator. I've seen tons of kids get problems wrong because they didn't put a parentheses around the stuff that they wanted to put to a certain power. Okay? Now, the terminology. Usually you can always say something to the something power, okay? But if you see something like with a little 2 to the 2nd power, people always say that is squared, okay? All right, that's what that means. Squared. You remember doing x times x, okay? That's x squared, all right? This would be cubed. 4 to the 3rd means 4 cubed. Okay, so you might see that terminology. After that, they got lazy and they didn't make up any names, so it's just to the 4th power, 5th power, 6th power, etc. Okay, and that's that. Okay, so you're thinking to yourself, what does evaluate mean? Well, I'm about to tell you what it means. In math, evaluate. Evaluate. Nailed it. 10 points for Gryffindor. Okay, so whenever we evaluate something, that means that we're going to find the value of it. Okay, value, without the E, 8, okay? I guess you can pull that E in. Hey, Lee. Evaluate. You're going to find the value of something. All right, since we've been talking about powers, let's do one of those, okay? Say you've got 4 to the 3rd power, or 4 cubed, okay? If you're going to evaluate, you're going to find the value of that. You're going to find what the answer is, okay? So you would do 4 times 4 times 4, okay? 4 times 4 is 16. 16 times 4 is Nintendo 64, okay? Let's say we did 2 to the 5th power, okay? That would be 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. That's how many of those we need, okay? So we do 2 times 2 is 4. Times 2 is 8, times 2 is 16, times 2 is 32. So 2 to the 5th equals 32. I evaluated 2 to the 5th. And that's what evaluate means. Finding the value of something. That's the end. Hello. What you're going to learn about now is called a verbal expression. Okay? A verbal expression is exactly what it says. Okay? You're expressing something verbally, okay? Whenever we, we had like the product of 4 and x, and we put it into an equation like 4 times x, we're doing the opposite of that. We're taking an equation and then making it into a sentence, okay? Essentially how you would say it. So let's say, that shouldn't be so hard. Okay, 2 plus x, okay? You could say, like say they wanted 2 verbal expressions for this. You would say 2 plus x, or you could say 2 plus a number x, because we don't know what x is. We could just assume it's a number. It's not going to be 2 plus a bird, okay? 2 plus x, or you could say the sum of 2 and a number x, okay? Or you just say the sum of 2 and x, okay? When you say a number x, it sounds a lot fancier, okay? And obviously it's a number. You're just adding a couple words in there to make yourself look good for your teacher. Your teacher's gonna be like, oh, Billy, you're so smart. And you're gonna be like, I know, right? All right. And then you'll get like a Letterman jacket for being so good at math. It's a pi symbol. What? Okay. So 2 plus x and then the sum of number x. At 2 and a number x, okay? Let's do one that's a little more complicated. Let's say we've got 4x squared minus 3, okay? We could write it out 4 times, because I'm just taking it one thing at a time, 4 times a number x squared minus 3. Okay? That's a verbal expression of that. Okay? It's a very ugly one because really all I did was list everything out. Let's make this look good. Okay? So what I'm going to do is I'm going to split this up into sections. Okay? 3 less than. Okay? So we know that's going to go at the end. We're going to take 3 away from whatever it is. Okay? 3 less than the product. That sounds good. That means you're multiplying, so I've included my multiplication. 3 less than the product of a number x squared and 4. Now you're thinking, why didn't you just write the product of 4 and a number x squared? Well, then you might think that you're wanting to square all this, when we're not. Our original problem just wanted us to square the x. So I put it first, okay? I said the product of a number x squared and 4, okay? I think that would work. I would accept it. And if your teacher doesn't, well, that's really their choice because they're your teacher. I'm not. I'm just a guy on YouTube or wherever you're watching this. Bye-bye. What up? Okay. So what I want to do is I want to show you essentially a cheat code, okay? This is a cheat code for if you're doing a power and say the number is 10, okay? Let's say we got 10 to the second power, 10 squared, okay? You're doing 10 times 10, which would equal 100, correct? Sure. Say you're doing 10 cubed, 10 to the third, 10 times 10 times 10, which would be 10 times 10, which is 100, times 10, which is 1,000. Now, I'm going to show you a shortcut for finding an answer when you have 10 to a power. You got 10 here, squared. Look at our final answer. How many zeros do we have? 2. 10 cubed. How many zeros do we have? 3. So, if you haven't caught on yet, through your mind of deductive reasoning and just raw intelligence and beauty, man, you look great today. How attractive are you? I say 10. See what I did there? Do you see? No? I should stop? Okay, I'm sorry. Okay, so let's say we've got 10 to the 6th power. Guess how many zeros we're going to have? 1, 2, 3, 4, 5, 6. And a 1. Okay? They like commas in there, so we know that's a million. All right? So that's what it is. Okay? Sound good? Do you get it? Does it kind of make sense? 10 to the 12th power. Instead of having to do all that work, just do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Stick a 1 on the front. Put our commas in there for funsies. And that's it. That's a shortcut. That's your cheat code on how to get 10 to a power. Okay. What up? Thank you guys for watching the math video. If you get a chance, check out tylertarver.com. I've got links to math videos and other stuff, whatever. I've got a math YouTube, which is, you know, what you might be watching this on, you might not, whatever. If you could subscribe to that. And then also, I've got a fun account. Let's see if it's fun. But if you could check it out too, it's got some math and then some other stuff that's less math. All math, some math, and other stuff. Check me out on Instagram if you want. Also, Twitter and Facebook. I know that looks like Tumblr. I'm just not very good. I have a Tumblr, but just Instagram, Twitter, and Facebook. If you're on YouTube and a regular one, you can click on these and go to them. If not, links in the description.